Okay, thank you, and welcome everybody. I'm Mark Sirrett from Surrey Lead Local Flood Authority. What we've decided to look at today is some uh, techniques and new elements that are in extra tools for the toolbox that are available to us. Mike and I, my colleague, attended some wonderful Syria training right at the beginning of the new standards that came in that Anthony on this presentation did, along with Bob Bray. And we came away from that very enthused, and also with the distilled message that thinking differently was an absolutely critical part of what we needed to do. So with the previous knowledge I had from working in my previous authority in Brighton, and I know we've got some people from Brighton on the call today as well, so that should be good for Q&A at the end. We had looked at Carlton Avenue scheme working with Bob Bray, and also looked at a trial using biochar and a comparison with crates, tree pit crates. So I wanted to have a look at that scenario and see what we can do. So biochar isn't new. We've just pretty much forgotten the global scale, the terra preta of the Amazonian rainforest, the black earth, the most nutrient absorbed, water absorbed, own climate creating soil base that's created from generations of thousands of years. That's under electron microscope. So you can see that it has a number of really key, unique features, which are not being fully utilised by us as a drainage industry, and I think could be very easily utilised. So to start with, it absorbs 325% of its weight in water, really quite useful, and that water is available to roots and filaments over quite a long period of time. If you want to know how it's made and what it is, it's effectively, imagine tree surgeon's wood chip, which is baked in an industrial continuous process to about 850 degrees in the absence of oxygen. It makes charcoal. It's then mixed with compost, manures, microbes then effectively get inoculated. That's the bio, and the char is the charcoal. So you can kind of picture what it is and how it comes about. More importantly, it drains like sand when it's wet. So it has both ends of that spectrum uniquely, and you can start to think, okay, well, I can see how that might be of use to us. Doesn't go anaerobic when saturated, so really useful for tree roots, and has very uniquely, if you ever did organic chemistry, covalent, both positive and ion bonds, so it attracts effectively all pollutants, all nutrients, whether positive or negatively charged. Think how a Brita water filter works. It's pretty much the same thought process. Also a powerful flocculant, which is a process which affects the way it attaches to these ionic bonds, and clay has a very strong particulate bond. So it's one of the reasons it's pretty much impervious, is it locks together quite nicely. This turns it into a friable structure, which improves winter catchment drainage. Really important for regenerative agriculture, really important for the way that we dispose of manures, and more importantly, hold on to pollutants, nutrients from the agricultural runoff going into our rivers. So quite handy that. Perfect substrate for microorganisms to exist, and enzymes and mycorrhizal fungi, which are the fungi that the tree roots use to convert the nutrients from what's available into what the tree needs. And more importantly, as an industry, permanently removes CO2 from the atmosphere. Once converted into the charcoal, it's there for 1,000 years or so. Some breaks down, but a very small amount. So as an industry, we're doing our bit. It's not by chance. The last couple of days we've hit record targets for heat. Taking CO2 out the atmosphere has to be 10 gigatons need to come out a year just for us to try and hold 1.5 degrees C. Even though we're on the right trajectory now, we've hit the crest and we're down the other side on removals potentially with CO2 from vehicles. But as an industry, we kind of need to be taking it out the atmosphere and doing our bit. It works by capillary action, same as if you drop a sugar cube into tea. That's quite important for flat surfaces. And it replaces potentially recycled plastic in drainage systems. The national standards go-to solution was crate and flow control. Now, I've rejected two this morning that work hydraulically but not hierarchically. So Anthony said when I first showed him, this is too good to be true. And it is the organic chemist version of alchemy. I don't mind having that quote. And Tom, you'll hear from at the end, knows it's been used for a long time in Sweden, which is where I went to do my research. So picture on the left is from the trial at the Brighton site, one of Ed Burton's contractors mixing up for the Stockholm tree pits from bags, which came from, I think that came from Carbon Gold. That would have been from Sweden at the time. It's manufactured in the UK now. And the stone on the right is rail track ballast. Stockholm tree pit being a large, weighty bulk of attenuating stone with the voids pre-filled with a biochar, and you plant the tree into ordinary compost, but surrounded by the structural soil. Bar swales, that's a standard drawing, but in essence, the base material is the same as on the left. And then structural surfaces for amenity space, you've got the biochar on the left, and the right is the stone they spread on the roads this time of year when the tarmac starts melting. So how is the structural soil made up? And this is where you're using in the highway only. And because it's stone on stone, you can compact it to meet motorway standards, so you can drive lorries over the tarmac, which means you don't need to lose parking space if you're putting rain gardens into the gutters to self-water or next to the gutters, or car park spaces. You can actually compact it to that level. So only use the granite. Anything else crushes when you compact it. The granite doesn't. Trees we planted into a minimum 1 metre square, but ideally a little bit larger, formed of either wood or concrete construction. We started with concrete construction. I've moved to wood, working on the basis you don't want the base, the roots to lift the base, and concrete won't move, so potentially that will have a lift effect. So I've gone to wood, which will rotted by the time the roots are formed and gone where you steer them, which is the point of the former. The biochar compost is between 25 and 30% there or thereabouts, and you can vary it depending on your location and scenario. That comes down to experience, but it kind of works between those two ranges. That's what pre-fills the 40% void ratio that you're all used to in filter type drains. Because it's pre-filled, doesn't silt, which is another advantage of this system. The biochar is 60 to 70% of that mix, the rest being compost. And the mix of that compost is then down to the person that's making the biochar themselves, and they will have the skills knowing what end users and markets they're using that for. And if you can add mycorrhizal fungi, you can buy that commercially, and you can add that in by hand if it's not already put in by the biochar manufacturer for tree purposes. Must be consolidated every 300 mil as you lay the pits up. I'll show you some pictures in a minute. And you must use an articulated BOMAG type compactor. We've tried other compactors and they didn't meet for highways. They didn't meet the highway specification. Whacker plate and tarmac rollers didn't work, so we had to go to a bigger, heavier system, and we needed a bigger machine to lift that in and out the hole. So you have to think about these things when you're planning them through. But you'll see some pictures in a minute. If you're using permeable tarmac, and silt will wash down through that, and we have done on some later projects, then the very top layer, I've not put any biochar into the top consolidated layer to leave some room for the silt to wash down through, and that seems to be working okay so far. Structural soil can go right down to the base of the pit. Your British Standard has been designed for this, but if you're on chalk or sand, because it's capillary action, you actually want the water to wick back up as well from below. So there we go. Rain gardens don't need as much consolidation. If you're putting in gabions, don't need any consolidation. It's not that's not in the British Standard, but we've been playing around with that and it seems to work. And you can use demolition screen crush materials, 40 to 80, but with no fines in it. The fines will stop the capillary action working. So biochar mix can be slightly less when you've got open topped and you're capping it off, because you can always add some more material to the top afterwards. You can't if you're putting tarmac over it. To higher levels of compost material when you're sealing it. You can go lower if you need to. For the structural grits, decompact the soil first. This is if you're putting in an event space, farmer's market, anything that you want to run grass on in the autumn when the ground's going to get boggier, Christmas, that sort of thing, Christmas markets. I was always being asked to fix the mess after the winter or early spring stuff, and this was a solution to doing that. So scaled down mix, vibrating 3-ton roller, laid at 100 mil, rolled it down to 75 mil, sow grass on it, water it and fence it off. You'll see some pictures in a minute. And there we are, fence it off. So here's picture top left from the Brighton site. That's the kind of finished article. The trees that went in were about double Hiras height size. We put in 30 cubic meter pits, the one directly in front of you, top left, a 30 cubed raised, a 15 cube raised, two tree pit crate systems, Green Blue Urban and ACO both supplied very kindly the systems for those. And we're doing a comparison site of elms in a Dutch elm disease site in tarmac, so the hardest thing that we could possibly do. Top right, we've got the tarmac roller, and where we did the consolidation of that, chap on the bottom left who was doing the testing. It didn't meet the highways deflection testing, so we came back with a bigger machine, and then it made the testing. So that's kind of a visual of what we're doing there. So from an LFFA point of view, if you're doing the heavy lifting with rainwater harvesting to meet first hierarchy, first standard, then picking up by picking up the rainwater harvesting first, all of the downstream elements that you can now add using biochar, so the bioswales linking management trains in the system, linking attenuating tree pits, rain gardens, whatever you're putting in, is then above surface, adding to BNG, creating your exceedance space, and in essence, helping you meet the standards while still locking away carbon from the atmosphere, so doing our bit. That's the picture this March, which is year 4 after the trees have gone in. Oops, excuse me. They're now double the height of the Muga where they were. The structural soils are slightly in advance of the crate systems now. Crates we know are brilliant and we know they work. They were at year 3 in the lead. The trees were larger, the girth was bigger. They had more compost to grow into, so logically that would work. I think the structural soils are now getting more water. They are more directly in the flow path. And the third tree in the raised cabin is behind the 2 crates. That's only a 15 cube versus a 30 cube. The 2 crates were 15 cube, but with a hybrid of structural soil around the outside to see how the roots permeate from the crates into the structural soil. Because that was information we didn't know about. And that will continue to carry on in Brighton and is a useful resource. The British Standard 8640 for structural soils has been developed. It's a bit of a one-size-fits-all, and this presentation is there to show you that there are some variabilities around that. It's quite expensive to buy. There is a discount of 15% if you join the Tree Design Action Group as an advert for them. But in essence, the BS8640 has a layer of draining clear material below it. We've been putting ours in all the way to the bottom, and we've been putting the air wells in. If you can see my cursor, these are the air wells. As water comes in, you need the air to go out, but more importantly, as the water goes out, you need the air to come back in and make sure the root, nothing stays anaerobic. That's the Achilles heel. If you don't put those in, the whole system doesn't work and the tree will die. So that we've been using culvert for those. This is Guildford Grove Primary School in Guildford, obviously. That's what a 30 cube pit looks like, 1.5 ton digger for scale, and that was the morning after the we had in the spring. The right-hand picture is mixing up the structural soils, not mixed particularly well at that stage. So I thought it's one of the pictures I used. You can see the stuff at the bottom isn't really well incorporated. The stuff at the top is a lot of biochar. They'd stop for lunch. I thought I'd take a picture and show you it halfway through. But that's using the demolition crushed concrete, which is significantly cheaper. And if you're working on a site where they're demolishing a building, circular economy, don't move it off site. You've got the raw material already there waiting for you. We're very lucky in that we've now got, say, biochar being made locally in Surrey, so it makes it easier for us. As more Shropshire have led the way with the first plants, as more councils are starting to get that in process, then getting it local is obviously keeping the cost down. These are the raised gabions, 3 trees in there. We've got these down to about 5,000 a tree, which is a reasonable price, I think, for a rain garden type scenario for this. Gabions are quite expensive. They're slower to make and produce. 500 mil below ground, 500 above ground. And the tree pits on the right are 1 metre below ground. There's a lot going on there that you can see with my cursor. That's the air well, bit of culvert pipe. We cut it off when we finished. And they're just putting in the no biochar top blinding before putting the permeable tarmac over the top. And that's the finished article with some tree seats that have gone in around it just to finish off for the school children. So on the biochar quickly, I think I'm all right on the bioswales quickly. I think I'm just about okay for time. That's a Syria manual type drawing. It can be simplified with biochar because you don't need the membranes because you're pre-filling all the voids. It doesn't silt. I would wrap a membrane around the pipe, and you can go for a smaller pipe if you're wrapping membrane around it. Put a 25 pipe in, you've got 0.8 flow under all circumstances. So you've got 1.4 on a hill, 0.8 on the flat, and you can fill that pretty much up. The other beauty is if you plant linear features along here, the trees next to it, or the link the attenuating tree pits along it, or hedges along the top, you can put those on the outside of gardens, and that adds to your BNG count. Inside obviously doesn't. That's a lovely one I discovered on my travels. Looks like lots of maintenance to me. We're covering warts and all on this. Beautiful design, headache on maintenance, but a straight linear feature on there for house design. And here's a house design that came through the office that had two rejections, and there were, when I got it, there were 30 odd complaints from the houses above that their gardens were flooding from the original site. It was an old nursery with a demolished large bungalow. So they went to permeable paving. That was tarmac on Mark 1. They've gone to attenuating tree pits with a bioswale, taking water along the top where my cursor's going and down. It flows from the drive down to a water course down on site. They've got rainwater harvesting on the first, I think, 4 houses from memory. It was about 300 mil drop from the top of the site to the bottom of the site. So they just couldn't get enough gradient in the top. But they've got bioswale running along the bottom. Oops, that one. They've got bioswale running on the bottom, and the rain gardens being picked up in the front of the property. So they're utilising all of those elements to pick up. They were 70% short of BNG. They're now back to square by utilising those and not having to get rid of the muck away off site from the demolition mix. This is some event space that I put in at the where we did that go in quite recently. Actually, it's only just grown in. That went in at the at the term end. That's the 100 mil being rolled to 75 mil with the biochar. It's a path for a disabled school. They wanted wheelchairs, but not tarmac. Tarmac path and growing area would have used 7 ton of carbon. That's inset nearly 30 ton. It all goes around the back of the area for bits and pieces. That's just the view. But you sow the grass into it. That was 2 weeks after sowing. We had that last bit of rain we've just had before it's got hot. Was perfect conditions for that. It's now fenced off. So this is the level at Brighton, which was Victorian rain garden. The area on the right is the grass with the 100 mil rolled down to 75 structure. Grass on the left is standard. This was taken in July last year. The grass is starting to cook. Water flows down here whenever it rains very heavily. And you can see that's green. There's some trees. There's 1 or 2 missing from ones we put in. And there's a big 45 cube willow pit just sitting in here to pick some of this water up. But you can see how green the grass is this side to that side. That will be like that in the middle of winter. And we have driven an Arctic twice across their tipping. So that gives you an indication of what we can do and how we can do it. And I'll hand over to Tom.
Thanks, Mark. I'll just share my screen.
I'll have to unshare when I.
Can you see that? You see that, Mark?
No, I've got.
Yeah.
Pardon? Yeah.
Got it.
Okay, so today I'm going to be talking about biochar and green roofs. If I can get the slides to move across. Oh dear. Okay, so brief introduction to green roofs for those who don't know, and why we are where we are today. So a green roof is a vegetated rooftop installed on essentially waterproofing, and generally includes planting, substrate drainage and protection layers. And when they came into the UK, they were seen as a practical way to slow and manage runoff, add some biodiversity, support some urban cooling and improve visual amenity. And they were generally developed as lightweight, free draining, and the kind of guidance that we have from our Grow Body Grow are understandably prioritising the structural loadings, drainage, consistency. And these are the right priorities for where the market is. But we have lots of drivers. So not moving to the next slide. We have lots of drivers that are pushing roof design in different directions. All the drivers you guys are aware of: SUDS, biodiversity net gain, the requirement for renewable energy, climate change as we're feeling it today. And the future is not just simply green roofs, it's blue-green, biodiverse, biosolar, water-aware, performance-led systems. And the future expectations are now broader of a green roof. You know, it's about water quality, it's about summer resilience, it's about making roofs multifunctional. current principles are not wrong, but future roofs are being asked to do a lot more, and traditional substrates are designed to get water away, where future green roofs and blue roofs need to hold the right amount of water and make it available at the right time. So, how does biochar play into this? Well, I find it quite interesting that the RHS, or Horticultural Society, is teaching the importance or the characteristics of biochar, and future horticultural students will be increasingly understand what biochar can do. They'll enter our industry knowing a lot more about soil carbon and moisture buffering and biological function of biochar. And students may expect future specifications to include more sophisticated growing medium thinking. You know, it the biochar within a roofing application or green roof application will retain nutrients. It will improve the runoff quality because it's pretty poor at the minute. It improves the moisture buffering. Um, you can store carbon within it. It improves the performance of lightweight engineered growing medium, and it improves the capillary action, which is really important to the green blue proposition. But biochar, whilst it has potential, it's only one part of the system, and it's. I don't believe it's the universal answer, and value really does depend on the type of biochar that we're using, how it's used, um, the, the, how it's produced, the particle size, what you're trying to achieve, if it's charged or not. You know, there's lots of things to consider about biochar, and it's not that biochar should be everywhere. It's that it's an ingredient within a more intelligent roofing system. And if it's poorly specified, there are real risks with it. You know, like I put on the slide, temporary nutrient imbalance, unsuitable pH, fines causing clogging, drainage issues on roofs, which is a big no-no, and variable performance between products if they're not consistent. But as we move on into the future and green roof proposition, water is a usable resource. One of the biggest shifts that we've seen in the industry, or we're seeing, is that roofs are being designed to get rid of water as quickly as possible. But the future is more likely to involve capture, storage, filter, reuse, evaporation, and passive irrigation. And biochar can play its part in that. And this change of role of water from a drainage problem into a site resource. This matters because of wildflower roofs, the wider green blue infrastructure integration, and summer resilience. Um, Water held on a roof should not be automatically seen as a problem because it can help with suds, water quality and filtration, biodiversity net gain, passive cooling and overheating, urban greening where space is limited. Water could be reused within the development, reused on tree pits, lower down in the development, reused on podium landscaping. Um, and it could be a very good way of climate resilience under heavier rainfall and longer dry periods. So the future home standard and the wider building performance thinking should be to push us to see roofs not just as finishes, but as part of the building's broader environmental strategy. Um, More project-specific modelling is required, but biochar can help support by having engineered media retain moisture, reduce the nutrient losses, and improve capillary action and runoff quality. I'll just skip this video for time. Why can't I skip it? There. Why won't it skip? Okay, so looking at summer resilient BNG and multifunctional roof performances, climate change means that future roofs will need to cope with longer, drier, hotter temperatures and the more extreme rainfall. And this challenge it's not simply about storing water; it's about keeping the systems on the roof more functional when conditions get more difficult. And we're seeing that with climate change. This is where biochar can help. It will hold moisture for longer. It will it will improve the substrate function. It will support healthier planting. it will make better use of stored water. So the future roof will need to be summer. Need to have a summer resilience strategy and not just a drainage strategy. The picture on the right is a client of ours where they didn't want to have a wildflower. They didn't want irrigation on a wildflower roof. There was two roofs. We said you've got to have irrigation, otherwise your wildflower roof will die. As an experiment, we installed at our cost an irrigation system to the top roof, and the client decided not to install it on the bottom roof, and you can see there's a massive difference. It's not science. It's not. It wasn't unbelievable to us. It's just demonstration. It's just a demonstration of what how these roofs will dry out. Come on. So a big opportunity with roofs is pitch roofs. Um, not all green roofs are just on flat roofs. As the pitch increases on roofs, we might need to introduce substrate retention systems, which we do and we've installed, and we know that work, and so that's fine. That's a given. But the retrofit is a major opportunity, and it brings real constraints. Structural loading and the existing roof limitations is the biggest. If roofs aren't designed to take a green roof from the outtake, it's very rare that you can retrofit. Um, but being able to produce lightweight multifunctional systems, um, where biochar will have a role in helping those lighter engineered systems, that's a real plus. And just whilst we're talking about retrofit, one area we could be starting to look at is moss roofs. They offer very lightweight options. Um, they require much shallower build-ups, lower nutrition input. They're less conventional substrate tests, potentially reduce the loadings. Um, and existing roofs have limited capacity. So biochar might help in the role in helping lightweight moss systems. So what does the future of roofing look like? Well, I believe that the roof will become a more intelligent environmental asset that will help the building and the wider development. It it will generate electricity through biosolar. It will capture and store rainfall through blue roofing, passive irrigation for planting, where biochar can have a real input. The filtering and improving the water quality, again, biochar can really help with that. Blue and green will contribute to thermal performance and overheating strategies. It will need to have biodiversity net gain included. And what's the important thing about biodiversity net gain is that it's not just about what that roof looks like on day one. It's about how it's monitored and maintained, and how it survives through the different extremes. And having more water available to the plants to survive is going to make BNG it, it enables you to achieve B&G without the requirements for obviously like irrigation and stuff like that, which is not required. So the future opportunity is a roof that serves the people, the building, the wider landscape, the drainage network, the biodiversity strategy, and the climate strategy. So the future roof is not a passive surface; it's a smart water, energy, biodiversity, and climate asset. So green roofs are evolving from lightweight planting systems into high performance environmental infrastructure. Biochar is not a silver bullet, but used intelligently, it could become a key ingredient in helping roofs store water, support life, improve runoff quality, and contribute to a more resilient building. That's uh, that's me. Anthony, shall I stop sharing? just on mute, Anthony.
Thanks, Tom. Or Tom. Yeah, thanks for the invite, Siwan, to talk about this today. I suppose I'm coming from very much practitioner point of view and looking at opportunities and what I bring to various other designs. I sort of was thinking about this over the last couple of days and thinking, well, in reality, I've been involved in suds design from around about 2003. I first got introduced to suds, so it's over 20 years now. So for the purposes of today's presentation, whenever I make reference to the old dog, that's me. And what I experience in terms of industry is there are constant evolution, constant new things come to the market, new products, new ways of doing things. So I suppose whenever Mark was saying earlier about the quote of me saying that's too good to be true, I suppose I was displaying my degree of natural and healthy skepticism, but also a natural curiosity as to what that could provide. So the next few slides are really just going to look at what we do as a company, what our thoughts are and what my thoughts are on it personally and professionally. Again, the guys have gone to lengths to sort of talk about the various ways that biochar is promoted and can be used. And it's really trying to self-check and make sure that we're using it in the right manner. Certainly from looking at a lot of the bioretention systems that are going in, a lot of them are highly free draining solids. And for me, from whenever I started looking at the specs around bioretention, I had a natural concern around the moisture retention over time, particularly during longer, drier months, where you have these soils that are really free draining. It's a really harsh environment and that sort of drought resilience. So if there's things there that can add to the equation, they're certainly worth consideration. In terms of where it can be used, again, Mark, I'm not going to, for purpose of time, I'm not going to go through these in detail. In most things where there's soils, that biochar can be used as an additive. It can be used for various reasons, various drivers, from purely carbon sequestration to improving the soil condition. So from my perspective, it's thinking about what is it we're trying to deliver through the design? What is it that we're trying to manage or mitigate? And what conditions are we trying to improve? What conditions are we starting from? So I was looking at those specs, looking at how we are managing those specs and what the end outputs should be. In most instances where we've used in the past, it has been sort of a fairly small aspect. It's in around that sort of 5% additive to the soil. And again, for the similar reasons of just giving that bit more resilience over the longer drought periods. We normally approach the soil design for specification for tree pits and things that are filtering pollutants out with not as free draining maybe as some others, to try and get that natural retention of pollution and get a good healthy soil, but adding the biochar as an additive to just enhance that moisture retention during the longer drought periods. So I suppose the opportunity is there to really start to look at it, to go into a bit of the background and research and understand what it is, how it can be used, where it can be used, and what can be done to improve existing situations. I did a bit of due diligence before today and had a look at a bit of research in terms of our own designs, qualifying to ourselves why we were using it, making sure, and I've sort of read some of the comments during the initial two presentations, and I would agree with a lot of the things that are being said. It very much depends on the quality of the feedstock. What's the quality of material that you're getting, and what temperatures are you doing the process at in terms of that treatment to create the biochar in the first instance will have an impact on what you get as an output. So you need to understand the quality of the biochar before you go in to really quantify the end outputs and the benefits you're getting. But there is definitely evidence out there to support. But I would probably stop short as saying and I would completely agree with Tom in saying it's not a silver bullet. It's not going to solve all problems instantaneously. It needs careful thought in terms of the proportions of material used, where you're getting feedstock, a range of different things to ensure that we're using it in the right way, in the right place. Just in terms of different other aspects, we've talked mostly about soils. There is some evidence to also suggest that it could be used within concrete products. And really, in terms of the concrete products, what we're talking about there is an additive to the concrete. The concrete is carbon heavy in terms of production. So there's a way to reduce that amount of carbon. So really what we're talking about is non-structural elements. We're not talking about supporting beams or things that have a high structural requirement. It's more curbs, paving slabs, paving blocks. Is there a way? In reality, you will be limited with the amount that you can be using, because the more you do in terms of inclusion, that will definitely start to drop off in terms of the strength of the material. So it's really looking at those sort of small edges of getting additional benefits and reducing the carbon requirements of any of the materials we're producing. Again, from a company point of view, we're not just looking at biochar, we're looking at how do we recycle materials whenever we're on site doing retrofit schemes. Any bit of depaving we do, any bit of concrete we lift, is there a way of crushing that? Is there a way of reusing that? So for me, it all forms part of a big artist palette in terms of the types of choices we have and the types of decisions we're making in terms of that design on site. Water holding capacity obviously is a really important part, and we've talked about the national standards for suds. For me, the most direct linkage in terms of that water holding capacity probably relates to standard 2, the requirement for rainfall interception and the ability to supercharge any of our suds components that we're putting in to ensure that that interception, that first 5 mil, is being retained. How that is quantified and backed up and demonstrated is probably a different thing we probably need to look a bit more at in terms of the science behind and the demonstration. But certainly, both from a demonstration against the SUD standards, but also just a pragmatic approach to designing for vegetative systems, if we can make them more drought tolerant. Given the weather we've had this week and last week and weeks to come, certainly drought tolerance and retaining as much moisture in particularly free draining solids as we can only be a good thing. So really, it's considering what it is we're doing and how we're using it. And again, it's been mentioned in the chat to date. There is a variation, and some of the research does give you quite a wide range in terms of the amount of water can actually be held, depending on what the feedstock is, what type of biomass you're using to create that, and the temperatures you're treating that at. So a few reflections. Again, I wanted to keep this relatively short to leave a bit of time for Q&A afterwards. For me, being the old dog in the equation here, and treating things with a natural degree of skepticism, but also being curious in terms of how things can be used. We have seen it being used elsewhere in the world. So really, rather than us being the guinea pigs, others elsewhere in the US and Europe and other places, Australia, have been looking at this. There is plenty of research out there. So it's really a matter of going and doing our own due diligence and making sure we understand the right protocols, the right methods, and where it can be used. There are other things we can throw into the mix here in terms of, I mentioned recycled materials and also smart technologies in terms of monitors and things that all need their own degree of scrutiny as we use them to make sure we're using them in the right place for the right reasons. Certainly, whenever I've looked at the research, I've found that it's more promoted and the benefits are more realized where you have soils that are more infertile and are more free draining, where you have healthy soils that have good soil chemistry, good soil structure going on, then those benefits decrease in terms of adding the biochar to it. So for me, it's being ensure that where we're using it for the right reasons. We understand the why we're using it. So we're not just using it because it's the emperor's new clothes and it's a new term and we want to use it. We're understanding why we're using it. And really that sort of falls back to having a real good understanding around soil chemistry. I think from a soils practitioner, from an engineering background, getting more and more into looking at how soils operate in a real world context where it's full of vegetation systems and nature-based solutions. Really, that level of understanding in the wider industry I see is one of the knowledge gaps that we need to fill. So it's ensuring that we start with the right soil spec to begin with, that we're not having to mitigate for inappropriate soil specs, would be my takeaway, or one of them anyway. And where we are trying to get highly free draining soils in for particular reasons, and whatever drivers we have come upon, that we have the additional tools that can support those soils to still have the resilience to sustain plant life, that we're choosing the right plants to the right place, and we're helping support those through the drought periods and through the nutrient retention. So it's not straightforward as I see it. There is a real degree of science there. There's a real degree of complexity, and it's up to us as an industry and as practitioners to really engage with that, to properly understand it and how it should be applied. So just in terms of final thoughts to round off and bring that back around to biochar in particular. I mean, it's a no-brainer in terms of if we're trying to do carbon sequestration and it's a primary project objective, then biochar will add benefit there. And I sort of mentioned a few times around the engineering soils that we're using, particularly around bioretention, that whether it's within tree pits, whether it's in bioretention cells that are on highways, there is definite improvements that can be made to those systems through moisture retention, just holding that water back, nutrient retention and pollutant removal. Where you have different soil specs that maybe aren't as free draining and they are already performing that pollution removal and water retention, then the added benefit you're getting will be reduced because the soil is already performing that task without doing the additive. So it's just making sure that we are knowledgeable about what the specs are that we're using and how we're having to adapt those for new considerations. So there's always new stuff to learn. That's one thing I've learned over the last 25 years in terms of being in and around SUDS. So it's something that isn't going to stop, and I expect over the next decade and couple of decades that there will be new things coming to the fore, and we'll learn more and more. So it's very much the start of the journey, not the end for me. And thanks for listening.
Thank you, Anthony. That's really useful. And there's some really good questions in the chats I've noticed coming through. And probably one of the most important ones from Sue was that, is there enough? And one of the things that I started looking at this about 5-6 years ago and tripped over a wonderful gentleman up on the Wales border, Newtown, Mick Jones on LinkedIn, carbon farmer if you find him. Once the engineering is there, and once the thought process is to turn what is green waste that would naturally in the carbon cycle go back to CO2, once there's enough of the engineering to lock that away. If you took the scenario that we have as a Surrey County Council, and we haven't got to that stage of producing our own, we're a few years away from that if we go down that route. But if you say we've got 110,000 tonnes of curbside waste, and as the most wooded county in the country, probably the same again of tree surgeons' wood chip waste that's sitting there being utilised in various functions. If you converted just the curbside waste, that's 300,000 tonnes of CO2 that effectively gets locked away. As a council, to be net zero, we're reporting just Surrey, not all the districts and boroughs after local government reorganisation, but just Surrey, something around about 16,000 tonnes short. So you can see that I think the decision, as the Climate Change Committee say, we've got to be doing more and faster. I think more plants will come on board. Walsall, I think, are live. There's a couple up north live. I think West Sussex are getting close to reutilising one of the machines that was Ricardo trialled down here previously. So there's more and more happening, and it's starting to go. The key bit is keeping supply and demand growth and quality and different markets for the right product segregated, and the right price for the right market and the right use. That's been pointed out in one or two of the comments. If a council works out that it's paying £25 a tonne to get rid of its green waste versus generating £300, £400, £500 out of the various elements that you can, the heat, the power, the biochar itself, then I think the market will catch up with itself quite quickly. And this 10 gigatons of CO2 we've got to take out the atmosphere will rapidly accelerate itself. But I think that's quite useful. Other questions in there, is the research there behind it there to do it? And when I started looking at this, there were about 1,100 research papers. It's now into the hundreds of thousands of PhD papers globally. And there's pretty much somebody somewhere, a lot of work's in China, but somebody somewhere has put a long-term study and profile into looking at a particular niche area of each of these bits that are in there. And I think if you, as Anthony says, do your due diligence and search, you'll find something absolutely specific to the really niche bit that you want to look at with the raw material and the other bits. But if anyone wants to ask any questions, feel free to stick your hand up and jump in. I think that's probably the easiest way.
Yeah, I think on the research bit, I've always found that the British Isles, Ireland, and UK, we tend to not necessarily accept what's happened elsewhere in the world. At all times, we want our own bit of localized research to demonstrate to ourselves it works in our climate, it works in our materials and our processes. So I would imagine there will be a bit of research either happening at present or a bit of future research around this area, because there is a lot of research happening right across the suds field in general. And I don't see any reason why you wouldn't put that into the equation there. What I would suggest is that we try not to repeat all of the research, and particularly where things are quantified to the nth degree, and really qualified to the nth degree. We maybe try and target around particular niches or areas that are specific to us as a nation.
Sue's just asked if you can stop sharing your screen so we get the whole picture of the person talking, and if that's possible. Yep. There we go. Magic. Well done. Any other questions? Any hands up? I think you can unmute yourselves. I'm not sure. Chris, can participants do that? Anyone else got any?
I'll put my hand up, of course. I always have something to say. So, given that I was just starting to write as a question, but given that most of us in practice and so on just haven't got time to check all the research and so on, which of all our various PIs is it Kaiwem who is going to sort of take on and guide us so that there's a kind of simple guide to what would be actually useful for different applications of biochar? Does that make sense?
It does. I know there's certain things happening in the industry at the minute. Syria are involved in rewriting the SUDS manual. So primarily from a drainage point of view, I know rainwater management point of view, there will be a new update to the SUDS materials, which will look a bit more in depth at soil materials and soil specs. And I would imagine, I can't absolutely qualify, but I can certainly check that biochar will be an aspect in around there. So there'll be a bit more guidance coming within the next 12 months or so on that. The wider uses, I mean, I know we're very much focused on SUDS today, but you could be using biochar anywhere in the landscape, that wider and plus the agricultural setting as well. That won't cover there. I would imagine there'll be other guidance coming forward at some point. I'm not sure where that would be driven from, whether it be DEFRA or elsewhere. You may have thoughts on that, Mark.
I've had conversations outline with HR Wallingford in terms of kind of the work they're doing and aligning the updates they're going. In terms of physically having trials in the ground and doing stuff, I mean, Meristem are chucking things in left, right, and centre. There's a whole lot of people who are getting to grips with it and getting things in the ground and showing and proving. And I think as we look at the large scale systems with AMP8 that the water companies are putting in, so that like what will follow on from the Mansfield project, as we get more and more large scale, and those people start to look at it because they're coming to these meetings, they're having a look at what we're doing, they're peering at the stuff that's working and going, we can see the advantages. It will trickle out slowly, but I think Sue's right. It wants a manual of some description and grabbing hold of and saying, here's the authoritative guide. But we're early, we're taking baby steps with this. I've made mistakes with it. I've killed stuff. I've got things wrong, and I take the Kaizen approach, chuck it in, get on with it, work out what works, and improve it on the next one. So, but
Mark,
it does
do you
need
mind
something
if
soon.
I say something, if that's all right?
Leap in, Lucy.
So there's been no mention of the British Isles Biochar Association. So it started up this year, I think. They had their kind of founding meeting on the 18th of March, 26. So part of the point of that association is all the things we've just talked about. So it would be worthwhile people having a look into that. You can join. It's not super expensive, like £100 for people that are kind of small scale interested in it, and then people who are at larger scale is a couple £100. And so the hope is then to try to build, a network, but also to work on those strategic pillars that we've been talking about, like things to do with education, quality, engagement with government, because there's quite a lot of constraints about where you can use biochar. I work in agriculture, so you're only allowed to spread a ton per hectare at the moment. What we've been told is that if you want to spread more, then you can do, but if you cause a pollution incident, then we'll have some prosecution. So we're like, so therefore we're not going to spread any more than we are allowed to. So they are saying that we have to challenge them to be able to get the loading rate increased, even though we've got researchers doing 100 tons per hectare in the big biochar project happening in Nottingham. So yeah, there's a few other bits happening there too. So just wanted to let people know that was happening.
That's useful, Lucy. Thank you. And we've also, I noticed from one of the comments, Alex is on the call, who is applying material to his own ground. So you might want to jump in, Alex, with that, because I know you've got lots of experience in that area anyway. If you're still there, you are. Leap in, Alex. Unmute yourself.
Hi, I'm still there. I'll just lower my hand. Yeah, Lucy, I don't know if you were at the Aston University session that Nottingham had the other week, and I'm also on a working group with the Beaver Association now. And you're absolutely right. I was going to jump in there and say about the principles and getting the market knowledge out there. And I think that this is a multi-nuanced discussion. So I'll just switch my video on so you can see me, and which we can go on for hours about. But I think that the application of biochar, you've certainly got to look at the standards and the quality of it and the consistency of it. I think that biochar has very different characteristics. Mark, sorry to pick you up, but charcoal is not biochar. It's a completely different characteristics. Charcoal is made between 200 and 400 degrees. Pyrolysis happens starting from about 480 degrees up to sort of 700 degrees. So there are very different properties. In brief, biochar will stay in the ground for centuries, whereas charcoal will degrade. This is the first difference. But in terms of for what we're talking about here in drains, there's a lot of evidence from the Stockholm tree planting now, which has been going for 10 years or so.
More than 20.
Yeah, so there's a lot of evidence there, and I think it's just getting that evidence out there. And I totally agree with the comments that were made. Biochar is not a silver bullet; it's part of the story, but it's got to be used in the right way. I think I'll stop there for the moment.
Thank you. That was useful because I noticed you asked a question, and so I thought, we'll do that. Kevin's asked a question: are governments interested in this area? And I think the background is the previous government supported a lot of the early research, The current one is looking very closely at what the European market is doing with carbon dioxide removal, and biochar is something approaching 90% of all credits for CO2 removed out the atmosphere globally. So Microsoft, Amazon, all of those who are buying colossal amounts from the big producers who are making hundreds of thousands of tons, then that is kind of, I think, where the UK government is going. Ed Miliband has been peering at it. I wouldn't say it's his top focus, probably even less so after this week. But I'm hoping that carbon dioxide removal is a critical part. If you looked at the Climate Change Committee's original target for what we have to remove, if each county council had one machine the same as Alex's, then we would have hit our previously reported targets. They've been moved on a little bit since, but that will be hit. Each council one using their own curbside green waste, so business as usual. So I'm hoping that the governments will be pushing this with government reform, because government reform is there to save money, and this generates money, and it generates savings. It generates downstream flooding cost reduction, which we know is an 8-to-1 kind of cost. So we are 1 or 2 minutes from time. Are there any other questions from in there that I've missed from the chat? Any of you? Anyone spot any questions I've missed? Anybody else got a
Mark,
question?
actually, just quickly, I kind of got mentioned a bit later, but your very first picture of the rain garden with the trees, you had wood chip, I think, around the trees, and I was just wondering if there is something like, so why did you choose that as opposed to wildflowers or anything else?
Yeah, so that has subsequently been planted up.
Okay.
It was for primary school, and the first thing the children would do would have been clambered into all the black stuff, and I'd have had literally carbon footprints everywhere. So that was an immediate fix to that. Where I've done it previously for the seating, it has worked quite nicely in that it reduces maintenance. Somebody asked a question on that earlier. It does rot down over time, so it does end up putting a bit more nutrient back into it if it's required, and it can be topped up easily. But they've subsequently planted all of that with a pretty much a north-facing fern herb, and I think they've got strawberries in there as well for the children. So that's a 2-rowan tree and a mulberry in there. 17,500 litres for roof attenuation that have gone in for that one was sitting at about 12,000 to put that one in from end to end. So, but I've used it to keep it looking tidy, because that's my experience in parks. No maintenance, no staff, do stuff that's the lowest weeding, the lowest control.
Well, you'd hope to not be weeding a wildflower planting, but sure, okay.
Yeah.
Thanks.
Good.
Yeah, I think it's weed suppression. There's different ways. If you can get quick ground cover, that would be another way of looking at it. There's different ways to do it. And I suppose it's elevating that level of understanding that there are different ways of doing it. It's not just chucking down bark mulch every site you see, because we see it more and more.
We have tons and tons and tons of it, and I needed a quick fix with 8 hours before the kids turned up. So yeah, more time, more budget. I'd have done something more beautiful. Brilliant. I think we're out of time. Thank you, everybody. I think I've found some stuff out I didn't know about, which is really good. Thank you, Lucy. We haven't met, so that's useful. And thank you, everybody, for coming. Anthony, thank you for helping. I know when I asked you originally, you thought, well, why are you asking me? But I think we've covered some good ground. So many thanks, and thank you for Simon for running this series. There've been some good ones this week.
Thanks, everyone.